Ladies and gentlemen, I think we're about ready to start. Thank you very much for coming and taking time out of your busy schedules to join us for today's session. Today's session is brought to you by BLM. We are a national and international law firm specializing in insurance, and historically we've acted for MGAs, cover holders, capacity providers and brokers. So we are certainly alive to the various models and relationships that MGAs have, and also aware of the challenges that you face on a daily basis. And we've actually collaborated with several MGAs with various initiatives in order to inform that process. I should also mention that BLM are a silver sponsor of the MGAA, and we look forward to continuing to support the association in the years to come. Today's session is focusing on data analytics and AI. Two things that we really want to achieve today. First is to demyth the jargon. You'll see that the title is Data and Analytics and AI Behind the Buzzwords. There's an awful lot of jargon that's floating around the market at the moment. A lot of it isn't particularly accurate. And what we want to do is to try and debunk some of the myths and the jargon that's floating around. We also want to explain the difference between certain distinctions within that jargon. For example, what the difference is between reporting and analytics. They are not the same thing. And also trying to sort of decode various meanings as well, such as machine learning, OCR, and even AI. The second thing that we want to achieve is also to explain a little bit, and one has to appreciate that it's very early days within this arena, is to ultimately try and explain how analytics can potentially help you as MGAs and inform capacity providers as well, and how it can serve as a useful tool, I think, to give you an edge possibly in your decision-making process, or enabling you to have a look at the litigation risk in your portfolio, and ultimately to hopefully improve your reserving models as well. Something that BLM is doing at the moment is entering into a 2-year partnership with the LSE, in which we're looking at prediction models, which will encounter things like reserving and decision making, and also hopefully as part of that prediction model to essentially give us as lawyers additional ammunition in which to hopefully advise you even better. So it's adding a different dimension to our advice, or at least that's the hope. Gentleman to my right that is going to give the talk and who has all the answers, or the most up-to-date answers I should say, is our own Andrew Dunkley at BLM. He was originally a lawyer at Herbert Smith before he transferred his legal skills to the world of data analytics. And so I'm delighted that he's on board with us. And given his background, I think he presents a unique blend of the practical, the legal, and the analytical. Before I hand over to Andrew, I just should say a couple of practical things. Slides that you see on the screen will be available at the end in hard copy. They will also, I understand, be uploaded onto the website of the MGAA. This session is also being recorded. So I understand that it will also be uploaded at a later date in the imminent future on the MGAA website. I think we should leave questions at the end for those of you that had questions, and we'll be happy to answer them as much as we possibly can. So without further ado, Andrew, the floor is yours.
Thank you, Alex. Good afternoon all, thank you for coming. I'm going to go over here on the screen. So what we're going to try and do over the next bit is a bit of a whistle-stop tour of reporting, of analytics. We'll touch on some of the words that get thrown around: artificial intelligence, machine learning, a bit about what they mean, a bit about how they work, a bit about what they're good for, and some of the things they're not so good for. So let's see how we get on. And we'll go from here. I gather we've got to have learning objectives to start with, which we've just touched on. So what we're after over the course of the next 45 minutes to an hour is we'll understand and talk about reporting analytics, how they're different, what they're used for. We'll look at some of the analytical approaches that we can use where we've got a lot of data, thousands of cases, lots and lots of examples. We'll talk through machine learning, AI, and their strengths and weaknesses. And we'll also get into how you can use analytics when you don't have much data, where you've got small samples, possibly high values. So kicking off, analytics and reporting. Reporting's been around for a long, long time. And what we're seeing happen a lot at the moment is reporting and analytics. They kind of get used interchangeably. But at BLM, we see there's a real difference between the two. Touching on reporting first. What we're trying to do with reporting is say, fundamentally, what happened. We have a sample of cases, however large. We want to know, within that group of cases, how did it perform? Maybe what happened, how long did they take? What was the cost? So we're looking backwards and trying to understand the facts. We often, in a reporting context, use dashboards. Now, they don't have, most people, I'm guessing, drive a car. All of our cars have got dashboards, and they kind of do the same thing. Dashboards are great for when you've got some predefined metrics, how fast am I going, that you need to periodically monitor to understand how you're performing. Am I going too quickly? Am I going too slowly? So we've got this touch point, this thing that we're going to measure repeatedly across all of our cases that we're going to come back to so we understand how we're doing. And because of that, we need to know for every single case what our metric is. How expensive is it? How long was it? How fast am I going? With analytics, we're trying to do something a bit different. We're trying to look to the future. What will happen next? The example I often use here is weather forecasting. Over the last 50 years, weather forecasting has come on leaps and bounds. That's using analytics to make predictions. They're based on the past, but they're using their understanding of the past, of what happened, and crucially understanding why it happened, to move ahead and look to the future. So we're using models to make sense of the world. We're building a model of how we think the world works, which means we can forecast what we think is going to work like tomorrow. Good example of that we see at the moment. We might produce a report that looks at the behaviour of a claimant solicitor firm. And we might see a spike in the number of cases that they resolve every March. Now, if we're using a reporting approach, we can say, right, it's February now. Next month, we can expect the same spike again. Sounds good. They spiked there like that for the last 3 years. Why won't it be this year? Well, a model gets into the why. So what we'll do with that is we might say, well, why are they spiking in March? Maybe because it's the end of their financial year and they want to drive up the numbers. But this year they changed their financial year end to July. So our model tells us, actually, no, that spike's going to happen, but it's going to happen a few months later. It doesn't always assume that what happened yesterday is going to happen tomorrow. It gets into why is it happening. The other thing we can do with analytics is we can sample. Because we're trying to build that model, we're trying to understand what drives trends rather than what's our overall performance. We don't need to have the data necessarily, the data point for every single instance we're looking at. We can take a sample. As long as that sample is representative, then we can get a good idea. A bit like polling. When YouGov goes and takes a poll for whenever the next general election is, they don't go and speak to every single voter out there. They take a sample that they think they can be representative enough of the electorate whole to trust and to scale up what they think, what those people tell them. Now, the flip side of that is it means you have to put a lot of thought into what's in your sample. You need to think through carefully which data you trust, which data do you not trust. Is the data that we have today representative of the book of claims or the book of business we're going to have tomorrow. If it isn't, then either your model or your report might be off. So we've got data, we've got reporting, and we've got analytics. Different things, backwards looking, forward looking. Now it'd be easy to say, oh, forward looking is better than backward looking. But that's not necessarily true. The reality is, we all need to understand how we're doing today. How fast are we going down the motorway? That we all need to understand how this is performing. But we also need to be able to do both and look forwards and say, where are we going tomorrow? What's the best route to get there? So you have to use the right tools in the right place. Just expounding a little bit here on that point between the difference between graph and a model. Graph on the left here, this is something we'll build in a report. In fact, this is something we have built in a report. Looking at the sort of example I just talked through, comparing the number of cases that we see and where a claim resolves in its life cycle to the market. But it's not really telling you why that's going on. This slightly scary looking graph, or illustration I should say, on the right, that's an illustration of a model that we've built to understand what a document is telling us. So they're actually documents, believe it or not. And what we're looking at here is how similar are different documents. On a screen like this, it doesn't actually mean a huge amount. But built into a tool, a model that we can use to make predictions about what those documents mean, it becomes valuable. So that's the difference between reporting and analytics. Now, for most of the rest of this talk, I'm going to focus on analytics, the forward-looking bit, which is primarily what me and my data scientists are focused on. Now, at BLM, we do a couple of different types of insurance claim, which I tend to talk about as high volume and high value. We don't have Amazon levels of data. We're not dealing in hundreds of millions of transactions, but we're still talking tens, hundreds of thousands of claims spread over the course of a few years. That's a plenty big sample size. So when we've got a lot of data, there's a toolkit that we can bring to bear involving yes, there's maths involved, there's computer science, there's also a fair amount of common sense and legal expertise. It's no good just throwing maths at a problem if you don't understand it, regardless of how much data you have. So there's a few things here that get thrown about a lot. And we did a press release a little while back where some colleagues of mine put together a document that had AI in it about every other word. And I sat down and I took the AI, all the references to AI out of it, and we sent it out into the market, and all of the articles that were written by various publications that covered it had put every single AI reference that I took out back in. People want to talk about it, but don't necessarily know what this stuff means. So we're going to touch on machine learning, using a computer, giving it data so that it can teach itself to make forecasts. We'll talk a bit about what artificial intelligence is, only really applicable where you have that large amount of data, because it relies on using the past to predict the future. There's also, and I was chatting to somebody over lunch who loves playing around with spreadsheets. We do a lot of that. We look at the numbers and try to understand them. We'll do statistical analysis. We'll do clustering, and we'll combine that with just speaking to the people that know about it. Again, mathematicians in a cupboard on their own, without expertise, probably aren't going to build the best models. Mathematicians that can speak to the subject matter experts, that have colleagues who can help them access expertise and subject matter knowledge, that starts becoming powerful. So we've got these things that we do. What do we try to do, use to do them with? Well, Alex mentioned OCR at the start. Anyone not heard of optical character recognition? Okay, so for those who haven't come across it, optical character recognition is basically a computer program that can read text as a picture and turn it into text that you can search. So it'll take a photocopy and turn it into a Word document, effectively. Now that sounds simple, but it's hugely powerful and increasingly powerful in the modern world as OCR technology gets more sophisticated. Because what it means we can do is, at BLM, we generate, well, when I joined 18 months ago, we had around about 20, 30 million documents stored electronically, lots of them in PDF format. My team reckons that's now doubled in the last 18 months, and that's going to continue to happen. We can now start to explore that documentation and pull out key facts. Now, in practice, that's going to have some real benefit pretty quickly. It means that there's a whole lot of boring MI that historically we've asked lawyers to input, that going forwards that we'll have a program that can pull out the key data points. But if we can automatically extract key data points, what was the injury? What was the address and the name of the person involved? Who were the parties? We had a debate in my team a little while back. Is your wrist part of your hand or your arm? Is your ankle part of your foot or your leg? Now, if you're capturing MI, you're manually someone's classifying, that kind of distinction becomes important. But if you can get into the document, somewhere in there, a doctor will have written down specifically which bone was broken. So we won't need to have that sort of semantic debate anymore. And because we can get it automatically, it means we can build tools that can assess documents as they come in. That becomes hugely powerful as we head into automation. We talked a little bit about sampling earlier and the power that that has. It means that we don't need to go and get MI for every case. One of the questions that I get asked a lot is, well, what if the data quality is rubbish? Or we've only been capturing this for 6 months. Is that a problem? Well, not necessarily, no. Because we can now apply OCR technology to a sample of cases to get good enough data to build models. Lastly, I've just put integrated data. To me, what I'm really saying there is we can pull data from all over the place. There's a lot of boring, not very sexy plumbing that goes into producing, reporting, producing analytics. Basically, it means going out, finding the data that you're after from whichever source it might happen to live in, ranging from nice structured databases through to documents, through to Excel spreadsheets put places, and pulling it into one place so that you can do something valuable with it. It's not fun, it's not sexy, it's often forgotten, but it's crucial. So now that we've got our toolkit, what are we actually going to try to do with it? Well, there's hundreds of different definitions of AI. I've got a couple here, and the reason I've referred to them, the reason I like them, is because they talk about how artificial intelligence is about teaching a machine to copy a human thought process. Let's just dwell on that for a second. So it's not necessarily thinking for itself. It's not intuitive. It doesn't think. It's not conscious. It doesn't have an internal monologue in the way that you're writing. It doesn't make creative leaps necessarily in the way that you're writing. So we have this idea in our head of the Matrix or Skynet. What we're really talking about here, especially at the moment, is much narrower. It is building a computer program that can answer a question that you pose it in a way that is indistinguishable from the answer a human person will give you. So if you ask a claims handler who's at fault, the insured, third party, or both, and you give the claims handler the facts, and you give your AI tool the facts, and they both give you back the same answer. And as the facts change, the answer changes. That's what we're aiming for here. It's teaching a computer to copy a person, or what a person would do. Lots of advantages there. It means that we can apply expertise across a whole swathe of places very quickly. It means that if we can pull it off, we're not necessarily reliant on a single person or a group of people having the knowledge or the perspectives or the experience, because their experience contributes to what your computer program recommends. Doesn't get hung over, doesn't have personal crises, doesn't work 14-hour days and get so tired it can't read documents straight. It doesn't have bad days or off days or good days. It's consistent. So what's it good for? Well, we talked just now about the second point there. You get fast, consistent decisions with quality that you can measure. You understand when you build this stuff how accurate it is before you launch it. It's also finding patterns that aren't obvious to humans. I'll touch in a second on how you actually how you build it and how it gets there. But what you're looking at potentially is systems that make connections between things that we call weakly predictive factors. So where you have things that play into the outcome of a claim that add up in sometimes unexpected ways. We built a model a little while back where we were looking to measure and understand the factors that impacted the outcome of a certain type of claim. And we tested it by teaching a model, building a model, and then removing factors one at a time to see how big an impact it had on the accuracy of the model we built. And we were talking about 2%, 3% drop in accuracy for each factor we took out. So not huge, but it all stacked up to a model that hit 85% predictive accuracy. It's got some downsides though. You need a lot of data. You need a lot of data to teach it. You need a lot of cases to make the business case to justify the expense of building this stuff. It's complex, it's expensive. If you don't have enough samples, if you don't have enough data to teach the intelligence, it's probably not worth doing. It also only answers the questions that it's trained for. If we built a model tomorrow and the law changed the day after, your model was only accurate yesterday. What artificial intelligence is doing is taking yesterday, taking the data from the past, building a model, using it to predict the future. If something changes fundamentally in the context that you're applying it, then you're out of luck. So again, you've got to use the right tool for the job, and you've got to think quite hard about it. There are an awful lot of people at the moment just sticking artificial intelligence on a product and trying to sell it on that basis. If you are looking at artificially intelligent products, whatever they are, think really carefully about them, what it's built for, what you want to use it for, and make sure those two line up. Because if you don't, regardless of how good the tool is, if you're not using it in the way it was intended, in the way it was built, you're not going to get the best value out of it. You might actually increase the risk involved. So how do you build this stuff? Well, there's a couple of different components that I'm going to talk about. Machine learning is another one of those buzzwords that gets talked about a lot. What we mean when we talk about machine learning is taking a whole slug of data. Let's pick some factors out at random. Let's say you might get 10,000 cases, and you might take the claimant solicitor, you might take the injury type involved, you might take whether it's litigated in person or not, and you build up a list of factors that you're going to give the computer. And you basically divide your 10,000 into a 9,000 strong training set and a 1,000 strong prediction set. Give it the 9,000 and say, right, put those 9,000 together in as many random combinations as you possibly can and build rules that you think will best predict the future. And you have a go, and you give it the other 1,000 and see how it does. And it might get half of them right. And then you'll go and say, okay, you got this half wrong, and you tell it which ones it got wrong. It goes and has another go. Maybe this time it gets 750 out of 1,000 right. You go back again and you iterate. So you're constantly retraining and improving and correcting the mistakes until you hit a level of accuracy that you're happy with. That iterative process is exactly how weather forecasting has gone from being frankly pretty rubbish in the 1940s, 1950s. We've also known Second World War films where the weather was rubbish and they were hoping it would get better, but it never did. The weather forecasting industry has been iterating its models, correcting smaller and smaller mistakes for 60, 70 years now. And I bet you don't often need an umbrella when you haven't got one anymore. Those days of stepping out the door without the right clothes, or without your umbrella, would need it, mostly gone, because they've been chipping it away at it for 70 years. We're going to be chipping away at this for a while, but it's only going to get better. You need a teacher. You can't teach a computer without someone to think, right, what's important? What factors do I need to give it? How accurate does it need to be? When have I given it too much? When's it getting too pernickety? There's something that we call overfitting. You can't just give a computer some data, buy a fancy piece of software, plug the two together, hit a button, and get AI. It doesn't work like that. There's real thought and real effort and real judgment involved in building one of these things. There is a huge amount of human input. So that's machine learning. There's other ways we can put together something that we could call artificial intelligence. You can base it off rules. We're doing one of these at the moment where we ran a series of workshops with some claims handlers to extract the detail of the thought process they went through when taking a really quite what I thought would be a really quite straightforward decision on fault for a particular type of volume claim. And we picked it because we thought, right, this is about the easiest, most straightforward type of decision these guys have to take. So let's start there. So it turns out those claims handlers are actually thinking about 43 separate factual considerations and a dozen different types of evidence in two separate contexts that they're all balancing out against each other. And that's for the simplest decision that we could think of. So simple decisions, actually, when you really break down your thought process, become very complicated. But you can extract it. You can build rules-based models on it. We are finding that we're getting good results. There's no machine learning in this. There's no training. There's not big data. What we've done is we've sat down and we've applied some serious thought to it. And we've come up with a model that, so far, is producing results that are indistinguishable from the same decisions that those claims handlers will take. So there's different ways of getting to it. Again, pick the right tool. If you've got lots of data and you've got resources, you've got time, machine learning is great. If the decision is reasonably simple, you're in a hurry and you don't have tens of thousands of claims to call on, you might still be able to get there with rules-based AI. Again, talk to the experts. Although it's not as reliant on data, you still want to validate it. It also can't get the subtle connections a lot of the time. A machine-learned artificial intelligence will be able to tell you, or may be able to tell you, that for this tiny little subset representing 1% of your total sample, there's something interesting going on. Machine learning might be better at picking that up and speaking to experts to pull out the rules. But this is easy to build. And this last point's important. There's a huge amount of academic research going on at the moment into explainability. Now, this is potentially extra important when it comes to AI in relation to law, AI in relation to importance. And we've all heard this, the saying that justice has to be seen to be done, as well as done. Well, a pretty crucial part of justice being seen to be done is understanding why you've taken the decision that you have. Lots of AI, especially machine learning, doesn't really give you that. It is a black box. It has taught itself. It gives you an answer, but it is pretty rubbish at telling you why it's recommended the answer it has. There's so many different millions of combinations it's put the data together behind the scenes that it doesn't know, and your code can't tell you. So you just have to accept it. You just have to trust the AI you've built. If you've got something based on rules, it's much more explainable. You can sit down, you can look at the tree you've built, you can understand, because you built it, you coded it, you can appreciate, right, it was this factor, and the weightings we've given them that have driven the recommendation that it's made. That explainability is not to be sniffed at. It's gone on from one too many. Now, there's a word I use there, which is something I talk about all the time, which is trust. So, when we come up with a model, we need to think really hard about how much do we trust this? How accurate is it? And is it accurate enough for what we want to do with it? And that will vary based on the amount of data we have, what the stakes are, whether there's a regulatory or a reputational risk involved. It would also vary based on how good people are at making the same prediction. If I come up with a model that's 70% accurate and our employees get it right 80% of the time, that's not good enough. If I come up with a model that's 70% accurate and our employees are only getting it right 60% of the time, that's a huge improvement. So context counts, and context will determine the amount of trust we place in the models that we build, or the tools that we buy. And that trust will then determine how we implement them. If we don't trust this stuff much, we can start out with effectively something that gives you a recommendation as an FYI. Here you go. I recommend that you settle this case, but just for your information, don't take it as read. Use your own judgment. As we move further along the trust ladder, we get some trust. Here we're saying, I recommend. You should do this. But we're still not automating. We're still not forcing people to follow what the AI suggests. Next step along is putting some policy behind it. You have to do what the AI recommends unless you've got your line manager's permission not to. And lastly, complete trust. This is where we're into full automation. We are automatically valuing cases without a person involved taking a decision about who's liable. We're automatically assigning tasks to people based on what the AI decides is the best strategy. We're triaging or making offer decisions in an automated way and other things. Trust is hugely important when it comes to AI. You need to think about how much trust we put in a particular solution and what that means for how we implement it. And that decision has to be made on a case-by-case basis. It's not something you can have a corporate strategy about because it's so context-dependent. I had to, on a strategic level, the best strategy is to think about it. But we don't always get lots of data. And I know in the MGAA context, that's often the case. Maybe we're a young business and still growing quickly. Maybe we're moving into something new. Maybe we haven't captured this data historically. So does that mean we're dead in the water and can't do any of this analytics stuff? Well, there's going to be things that are trickier. Artificial intelligence, using machine learning. Without the data, that's a struggle. Rules-based AI, more achievable. There's things we can do there. But it doesn't have to be a roadblock. We just have a different toolbox. We tend to use more statistics, less artificial intelligence, less machine learning. So I'm going to talk through decision trees in a bit more detail over the next 10 minutes or so before we come to some questions. That's something that we're working a lot with at BLM in relation to higher value claims or lower volume claims. Similarly, Monte Carlo simulation, that is taking a hypothetical portfolio of claims, weighting them, and then seeing how they perform when you run them randomly, so that you can simulate from a small number what you think would happen if you had a large number. So we can still build tools to take better decisions, even if we don't have data. Don't be put off by the fact that artificial intelligence is expensive or complicated or difficult, or you don't have the data, or whatever the problem is. If you want to use analytics, if you want to use an analytical approach to take better decisions, lack of data isn't necessarily a barrier. So I'm just going to talk through this as a bit of a case study, because it's a tool that we've built internally and we're piloting at the moment and getting some really good stuff out of. So a decision tree is effectively a flowchart. It's a series of questions where you assign probabilities that A or B is going to happen, and then a cost or a value if it does. So what we have here is this pretty simple model based around liability, quantum, con-neg. Is it going to happen? What's the percentage if it does? And what you do is once you've asked your question, how likely am I to win a liability? If I win a liability, I moved more than I was expecting, I thought that was a wall. If I win on liability, is the judge going to come down on my side or their side on quantum? And what's a reasonable number there? And what you can do once you've got all those answers is basically multiply them out and then average them, and that gives you an indicator of, if it went to trial, what would the likely outcome be. But we can go further than that. So one of the things that we're now doing at BLM is we're using this plus some other statistical modelling to produce liability curves for one-off cases. So what you're looking at here is a visual representation of the risk distribution, the liability distribution for a single high-value case, hypothetical one, which gives us a much more sophisticated conversation to have about the risk involved, as if we just said, oh, we put this number on it. What you probably see with this, if you had a best guess of the most average, most likely outcome, is the average most likely outcome is probably somewhere in here. Somewhere about 150, maybe 200. Now, if you were thinking about reserving on this basis, reserving at 150, 200, yes, it can, if you had 10,000 of these cases, that might be fine, because it's the average overall outcome. But if you've got one, then you have a decision to make. Are you going to reserve where you think is most likely to account for, to come out? Or how much of the tail risk do you want to take into consideration? Question mark. That's going to be a decision that you need to have with us, within yourselves. But if you can't see it, you can't have the conversation. There's other things we can do. We can start to understand for any given settlement offer valuation, how likely am I to do better or worse if it went to trial? On this one, you can see our 50% line is somewhere around 4.75, 4.8 million. But you can also see there's quite a high uncertainty, quite a broad range around that. So, if an offer comes in a bit above or below it, well, maybe you can have conversations about risk with this sort of approach that you can't if all you've got to look at is a single number. If you put a value on a case of 10 million, that's not necessarily saying anything about whether the 50% range is 9 to 11 million or 5 to 15 million. that's what, how much confidence you have in that 10 million is going to have a big impact on what the appropriate strategy is, both for managing the case and for how you handle it internally. So what's the value of this sort of thing for you guys? Well, as you can possibly guess from the conversation that what I've been talking about, having a robust reserving model counts. It helps you take better decisions earlier. Some of these tools, especially the decision trees, they're designed for use when you don't have lots of data. And that includes right at the start of a claim, before you've seen any documentation. You can still apply this sort of thought process and this sort of technique way before you get to expert witness statements and lots of legal expense. My analogy for the claims process is poker. Poker is a great analogy for litigation and claims, because what we see with poker is you start out knowing a bit, and the other guys know a bit. And throughout the course of the claim, we're going to turn over more cards. But we've got to pay to do it. Now, at any point, we can agree to value the case and walk away. Now, if you're playing poker, what you don't want to do is pay to see all 5 cards and then fold. If you're going to fold, you want to be able to do it up front, early. You don't want to pay all the way through and then settle. It's the same thing here. We're trying to help people take better decisions earlier in the case when there's less information available. And in high-value cases, that's tricky. So another thing this does is it provides a second opinion from yourself. We're helping lawyers make good advice better. And we can then adapt that throughout the life of the claim. So what we've got with an approach like decision trees is a better forecast early in the life of the claim based on less information, but then evolves as you go through. And that's not based on tens of thousands of cases. That's not based on artificial intelligence or super expensive technical buzzwords. It's based on expert knowledge applied in an analytical way at the outset of the claim. Thank you.
Thank you very much indeed, Andrew. We do have some time for some brief questions. Has anybody got any questions for Andrew at all?
Lots of blown minds.
Whilst they're thinking, Andrew, I'll throw one in and then we'll go to Duncan. It seems to me that a lot of what you've been talking about, whilst quite scary, potentially the death sentence of a claims handler on the small claims, it seems to be responsive to what's been going on. You talk about analytics and predictions. So let's look at the contract of insurance in itself. Will it then start to look at, let's say, we want to write something to do with a new class of business? Will it be able to pull together all that data that's out there on the cloud to start to predict what that contract of insurance would look like going forward?
So this sort of tool and technique is being applied across the legal industry in lots of different ways. We're focusing on the claim side. However, I know for a fact that there are people out there who are, this is what OCR lets you do, developing the ability to work out what is market standard, how is it changing, to pull relevant clauses from lots of different contracts across an organisation and understand, new contract comes in, some new drafting comes in, is that too harsh relative to the market, not harsh enough? So that's exactly where it's the direction that this is going, or one of the facets of it. The other thing I'll say, talked about death of the claims handler. There's a lot of people out there, and one of the questions that I get asked very frequently is, so Andrew, you're the guy who's trying to put me out of a job. And my response is, well, I don't know that, to be honest. There's anyone that says in the future there's going to be tons and tons of people made unemployed by technology is probably a bit overconfident. So we're working with some claims handlers at the moment. We still need them to actually tell us whether they think the witness is reliable, whether they can trust the person, the person making the claim or the insured. That there's still subjective elements in there. There's still witness statements need to be taken. Expert reports need to be drafted. So I don't know. I can see different worlds. There is a potential outcome of this where technology takes over some jobs. But there's also potential outcomes to this where technology supplements people doing those jobs so that they do them better. But you can't necessarily take the person out. So possibly on the our claims handlers do front. And yeah, I think anyone that's really confident that we're going to see no more claims handlers, I don't know. I'm not quite that confident an advocate of this stuff. Sorry, but there was one over here.
Hi. I've been involved in some big complex claims that have, if I stretch it, feel like a bit like a game of poker. But my worry is that in the sort of middling claims, or the high volume claims, that if you apply the AI developed around that concept to ones where that balance, where me as an individual householder, I don't have a lawyer or two standing behind me, that just that sense of it's a game of poker, and AI can help you play it quite more better. Do you not feel that's a worry rather than a trust?
I mean, I'm a solicitor. So as a solicitor, I still have a profession. I'm still not practicing certificate. I'm still bound by my professional duties. Number one of which is to act with integrity, and number two of which is to act in the best interest of my clients. And those two can be in conflict sometimes. I think you are entirely right that there are real risks and real ethical worries about this sort of thing. You have to be, it's something that we think about, I certainly think about it in all the time. We saw it with Cambridge Analytica, the extent where they were profiling individuals and trying to play with their heads. But here's the thing. So when a lawyer without a computer gives advice, they're trying to manipulate the other person. They're trying to induce the other side to accept a settlement offer that is beneficial on their own client's terms, not necessarily in the other side's best interest. But that sort of relationship is necessarily adversarial, and the whole system relies on a bit of a tug of war for it to end up in the middle. There are real questions that I don't yet have all the answers to about where the ethical boundary is. At what point are we being too aggressive with technology? At what point are we using technology to, at scale, to unethically manipulate and take advantage of other people? It's something that yes.
No, I was just going to say, the sort of same sort of thing happens, for example, right now. For example, for recommendations, judges recommend sentencing, for example, they are using AI. And one of the questions that's come up is, for example, that the AI is essentially profiling, because if you feed it a lot of cases of a certain type of ethnicity or a certain type of background or person, it's going to pick that person as being more likely to be okay.
You're exactly right, and you've got to be very, very careful. This is why putting the model together and the information you give it is crucial, because you can profile without realizing you're profiling. You can make your, in our world, if we try to make a machine sort of colorblind, so we're not giving textual cues that might give indicators about someone's ethnicity, include their name, possibly their address, but it might also include things like the words they use, or the job they do, or the type of car they drive, or where they live. And those sorts of things are much harder to pull out. Yes, it's a huge problem, and Facebook and Google get caught out by this stuff. There was I'm sure some of you have read about Facebook and Google using face recognition software that hadn't been trained on enough Afro-Caribbean people, so it couldn't recognise them as well as it could recognise Indo-Caucasian people. And the best defence of that is thought and vigilance. We can't get all the way there. all we can do is do the best we can. We can make sure that we think about this stuff when developing the tools rather than just sprinting forwards into the future. We can make sure that the teams developing these tools have different backgrounds and different perspectives, and aren't just a bunch of white mathematicians in a cupboard, blokes. To anyone that's out there, please get your daughters to study maths and coding. It's so difficult to hire a non-male data scientist. So there's things like that as a society we need to grapple with. We need to make sure that the teams that are building this stuff are diverse, and we need to make sure that they are empowered and have time to think about the ethical consequences of what they do.
Any further questions before we wrap up? No? Okay, well, thank you very much indeed for coming. That concludes today's session. Many thanks.
Thank you.